Right, so in section 38, we're actually going to split this up. So we're going to start by solving and writing absolute value functions, and then from there we're going to go to graphing transformations of an absolute value function and graphing absolute value functions. So starting. So go ahead and compute this entrance slip. Let's compute each of the following. So anytime that you have something inside of the absolute value signs, your output is always going to be positive, which means that your y value or whatever you get is your final answer. That's always going to be a positive number. So numbers 1, 2, and 3, go ahead and pause the video and solve them real quick. So hopefully you got 7, 0, and 4. So anything that you put in always comes out positive. So you're always solving what's inside first and then getting that positive answer. So here we go. For solving absolute values, these equations. So you're going to have the absolute value ax plus b closed absolute value equals c. So a, b, and c, those are all numbers. So whatever you do, no matter what, you always have to make sure that the absolute value is all by itself. So if you have a number in front of the absolute value or another number on the other side of the absolute value, you always have to make sure that you get that absolute value by itself first. So when necessary, isolate it. Then you're going to separate it. One's going to be normal, and then the other one is going to be the opposite. Okay, so the note actually goes with step number 2. You're always going to have one that's normal, and then the other one you're going to take the opposite, which is why we have that negative sign there. And then from there, you're going to separately solve for x for 2 answers. You are not always going to have one positive answer and one negative answer. That's not always true. Sometimes they could both be positive and sometimes they could both be negative. It just depends on what's around it, okay? So we're going to do numbers 1, 2, and 3 together. So notice that number 1, the absolute value sign is already all by itself. So we have just add the absolute value of x plus 9 equals 24, which means that whatever we plug into x, then add 9 to, then we have to take a positive number, and we need that number to be 24. So what I'm going to do is I'm going to split that up. We're going to split it up into x plus 9 equals 24. And then we're going to take the opposite. So you can either put a negative sign in front of it, then you'd have to distribute. So that's one way to do it. Or you could just flip all the symbols, negative x, and then we have minus 9 equals 24. From there, you're going to go ahead and solve. So you're going to solve x plus 9 equals 24. And you're going to get that x equals 15 because you're subtracting. And then we have negative x minus 9 equals 24. So we're going to have to add 9 to both sides. So you get 33. So we have negative x equals 33. Divide each side by negative 1. And you're going to get that x equals negative 33. So this is our answer. Number 2. For number 2, you have to isolate the absolute value. So I need to get this all by itself. So what you're going to do is add 3 to both sides, so that that negative 3 moves over to the other side. So now we have the absolute value of 2x plus 6 equals 16. From there, you're going to go ahead and split it up. So one's going to be normal, 2x plus 6 equals 16. The other one is going to be the total opposite. So we're going to take, we have negative 2x, and then we have negative 6 equals 16. So 2x plus 6 equals 16. We would subtract 6 from each side to get 10. And then 2x equals 10, divide each side by 2, and you get x equals 5. Take some time, write out the work if that's something that you guys need to do. The next one, we have negative 2x minus 6. So you would add 6 to each side to get 22. 22 divided by negative 2 is negative 11. All right, finally, this third example. So we have a lot going on this one. You have to get the absolute value all by itself. So the first thing that you would do is add 5 to each side. So you have 6 absolute value, 3x minus 12 equals 54. Then you'd have to divide the whole thing by 6. 6's cancel, so you're left with the absolute value of 3x minus 12 equals 9. From there, now you can go ahead and split it up. So when you split it up, you would have the normal, 3x minus 12 equals 9, and then the other one you'd have the opposite. So we would have negative 3x plus 12 equals 9. Go ahead and solve. the top one and the bottom one. Get your answers, pause the video. So we got x equals 7 and x equals 1, which are the correct answers. Okay, if you were to plug both of those in to x, you would get 49 both times. So 49 equals 49, that's the correct answer. So both of them are positive. Don't think that that's always the wrong answer, because in this case, it was true. Okay, so if you are in 2021, you are going on to number 14 at the end. If you are in 2022, you are doing numbers 3 through 6 right below. So go ahead and try these 4 problems out all on your own. Check up top, pause the video, do the work, and in a second we'll be back with the answers. All right, go ahead and check your answers. Pause the screen. Number 4, you should get x equals 8 and negative 18. Number 5, x equals 14 thirds and negative 6. Number 6, x equals 7 and negative 8. And then in number 7, we have x equals 8 and then x equals negative 16 thirds. All right, so that was solving. The next thing that we're going to do is write a piecewise function. So writing a piecewise function, these absolute value functions are all actually split into two different lines, okay? The graph of it actually looks like you'll see on this next page. So this is the actual graph of an absolute value. Notice that on one side, so here's 0. On the one side, we have a positive slope, and then on the other side, we have a negative slope. Okay, but notice that everything on the right side is reflected on the left side, and they both stem from the 0, 0. Okay, so every absolute value function is always going to stem from one single number, and it's going to go in two opposite directions. So these piecewise, the absolute value functions are actually piecewise functions. So the first thing that you're going to do is make sure that we write the absolute value expression without the absolute value symbols. So the first time that you're going to write it is normal, and then the second time you're going to write it is going to be the opposite. So we have normal on top and then opposite on the bottom. So then you're going to take just what's inside of the absolute value symbol, right? Just that. And what you're going to do is you're going to put just what's inside the absolute value sign in these two lines. In these two lines, you're going to have on top greater than or equal to 0, and then on bottom less than 0. And it has to be exactly written like this. So we're going to have greater than or equal to 0 and less than 0. Every single time, these two numbers are going to be the same number every single time. What you're going to have to do over here is you're going to solve for x. You're going to get x all by itself. So you're going to solve for x. So you're going to have two separate inequalities. All right, well, let's take a look. So we're going to go ahead and write a piecewise function for f of x equals 4x minus 12. All right, I'm going to start by writing f of x equals, and then we have our bracket. On top, it's going to be normal. So I'm going to write out the normal 4x minus 12. On the bottom, you're going to put the opposite. So we're going to have negative 4x, and then we have plus 12. All right, then we're going to have to write out the inequalities. So you're going to take just 4x minus 12. We're going to put it on top and the bottom. On top, we're going to have greater than or equal to 0, and then on the bottom, we're going to have less than 0. All right, we're almost done. You just have to solve and rewrite this part. We've already simplified 4x minus 12 and negative 4x plus 12. You can't do anything with that. However, we're going to solve for x here. All right, so we would add 12 to each side. So we'd have 4x is greater than or equal to positive 12. Divide each side by 4, so you'd have x greater than or equal to 3. Now, if you were to do the same thing on the bottom, you'd have to add 12, and then you'd have to divide by 4, so then we'd have x less than 3. So notice that it's the same number, so you just have to really solve one of them. So what we're going to do from here is we're going to rewrite this whole thing. So we have f of x equals bracket. On top, we have 4x minus 12. Next to it, you have to put x greater than or equal to 3. Then we go on to the next line. So we have negative 4x plus 12. Next to it, we have to put x less than 3. And this is your final answer. So I'm going to box this up. All right. You would do number 9 the exact same way. I'm going to go ahead and pause the screen and write out number 9. So why don't you pause the screen, try out number 9, and we'll be back in a second. All right, so we have g of x equals, so we were able to write the same and then the opposite. So we have 8 minus 4x, and then we have negative 8 plus 4x. Now, the only thing is that for this problem, when we solved, so over here I set it up, so we have 8 minus 4x greater than or equal to 0. I subtracted 8, and then I divided by a negative number. So going back to unit 1, whenever we divide an inequality by a negative number, we have to flip the sign. Now in the bottom one, because they're exactly the same, when you would divide by the negative number, it would also be a sign flip. So we have x is less than or equal to 2, and then we have x greater than 2 as our inequalities. So this one was a little bit different because we were dividing by a negative. So super important, whenever you divide by a negative, flip the inequality. This is the only example where we have to do this. All right, number 10. So in number 10, we have f of x equals 3x, the absolute value of 3x plus 2. So we're going to start by writing out our f of x equals and then the bracket. So on the top, we're going to put the normal. So the normal version is 3x, and then we have plus 2. On the second line, you only have to take the opposite of the absolute value. So just the opposite of this, which is instead of positive, it's going to be negative. So we have negative 3x, and then leave it as plus 2. Now, for the inequalities, you're only putting this, whatever's inside of that absolute value. So we're going to put 3x greater than or equal to 0. The top's always greater than or equal to, and the bottom's always less than. So we have 3x less than 0. All right, just what's inside that absolute value. So we're going to solve. We're going to divide each side by 3. So we're going to have x is greater than or equal to 0. 0 divided by 3 is just 0. So let's go ahead and rewrite our absolute value, or not our absolute value. Let's rewrite our function. So we have f of x equals, we have 3x plus 2, and then we have on the bottom negative 3x plus 2. And then for our inequality, we have x greater than or equal to 0, and then we have x less than 0. And this is my final answer. All right, let's try it again with this number 11. So number 11, we have g of x equals 2 absolute value 6 plus 4x. So on top, we're going to write it normal. So we have 2. I'm going to put parentheses here because we will have to distribute that 2. So we have 6 plus 4x. And then on the bottom, we have to put 2, and then we have to put the opposite. So I'm putting the opposite of what's inside of here. So the opposite would be negative 6 minus 4x. After that, we're only putting what's inside of the absolute value for our inequality. So we're going to write 6 plus 4x greater than or equal to 0, and then we have 6 plus 4x less than 0. Go ahead and pause the screen. So you're going to distribute right here. You're going to simplify, and then over here for the inequality, you're going to solve. So keep going and solve this problem out. I'm going to go ahead and pause my screen. So our final answer, we have g of x equals bracket 12 plus 8x for x greater than or equal to negative 3/2, and then on the bottom line we have negative 12 minus 8x for x less than negative 3/2. So again, those inequalities always the same number. Go ahead and pause the screen and try out all of numbers 12 and 13. When we come back, you'll go ahead and see both answers. So here's our work for number 12, and then number 13, there's the answer. So these were just a couple other questions that people might have had. So solving that inequality for number 13, and then solving that bottom part, number 13. So these are answers for writing out a piecewise function from the absolute value, and then earlier we were solving.